Hi, this is Matthew from BMI Academy. Question 3. This asks you to define rectilinear propagation of light. That one is straightforward. Rectilinear propagation of light is just the ability of light to move on a straight line in one direction. Ability of light to move on a straight line in one direction. Okay. So the second case is asking you for reflection. Reflection is the bouncing back of a wave or the repropagation of a wave after hitting a surface. Or in order to manage time well, I would just allow you to write that yourself. Dispersion itself is defined as the separation of light into its component colors. Okay, so for reflection, I said it is what? Repropagation of a wave, or it is the bouncing back of a wave after hitting a surface. Okay, while what have we? Dispersion itself is the separation of light into its color component. The color component of white light is what? Rooiwave. So when white light breaks into its rainbow color, this is what they call dispersion. Polarization. Polarization of a wave. I've talked about this initially. We said that it is the restriction of the vibration of a wave to a plane. Restriction of the vibration of a wave to a plane. This is called plane polarization. Restriction of the vibration of a wave to a plane. Okay, that's the simple definition for it. Then we have diffraction. So diffraction is the bending of a wave due to an obstacle placed along its path of propagation. Bending of a wave due to an obstacle along its path of propagation. If you don't want to use the word obstacle, you can also use open slit. Obstacle or what? Open what? Open slit or open slit. Anyone you want to use is okay. That's what how you define diffraction. Then we have the next question. This is a calculational question, which is what we have here. Okay. So the question says that a glass plate is 0.6 centimeter thick. So you have a thickness. Let's call that D. I don't want to use T for time. So let's just use D. 0.60 centimeter thick. And as a refractive index of, that's the absolute refractive index 1.55. How long does it take? By how long we need time? How long does it take for a pulse of light incident normally to pass through the what? To pass through the glass. So the question wants to know the time it's going to take for a pulse of light to do what? To pass through the glass. So how do we go? How do we solve this particular problem? Okay. Let's see. We have this to be, let me give you a visual representation. So this is the prism here. So the question gave you the thickness. We need what? We need, okay. Once we can get, we need time. Sorry, yeah, we need the time it's going to take for it to pass through. Did they give us event? Hold on. So we know that n equals to what? C over what? Cm. Okay. So where c itself means speed of light in vacuum. So we can get speed of light in the medium. You get? So knowing the speed, we can go ahead and then get what the time. So let me use a proper space. N equals to C over Cm. Therefore, we have it that the n given in the question is 1.55. So we say 1.55 equals to the speed of light is a constant that is approximately 3.8 meter per second over Cm. So from there, Cm is going to be 3 times 10 raised by 8 divided by what? 1.55. So what do? You do 3 divided by 1.55. So that gives me Cm to be equals to 1.9. Let's approximate it 1.94 times 10 raised by what? 8 meter per second. So if that's the situation, we can then say that what do we need? Distance is given. The distance, which is the thickness, is given as 0.6. Where is it again? Yeah, 0.6 centimeter. 0.6. Hold on. 0.60 centimeter. Let's convert that to meter. That's 0.6 over what? 100 meter. So what do we need? We need time. Don't forget that distance, velocity equals to distance over time. Remember? So from there, the distance is going to be equals to velocity times time. So our velocity is c, then times, what do we need? We actually need the time. Let's make the time the subject. T is going to be equals to d over v. So that's 0 what? 6 over 100 divided by what? V, which is we're using c in this case, so 1.94 exponential 8. So that's going to be, we have point 0.006 divided by 1.94 exponential 8. So this gives us 3.09 times 10 raised to the power of negative 11 second. So this is the time it's going to take. Okay, I hope we do not make an error there. That's the time it's going to take for the light to pass through the thickness. Okay, so what's the next question that we have? Okay, the next question is on concave and convex mirror. Okay. According to the question, it says a convex mirror of radius radius of curvature 20 centimeter produces an image of an object positioned at 30 centimeter from the mirror. Determine the distance between the object and the image front. So what do you do? The first thing should be to write down your parameters. This helps you bring more clarity to the problem. The first statement, a convex mirror. Take note of that. Convex mirror. So it plays its own role because that's how you determine the nature of the focal length. The focal length in this case is going to be negative. Question gave you a radius of curvature to be 20 centimeter. So this implies that our f is going to be r over 2 since r is twice f. So this is 10 centimeter, but it is going to be virtual. Why? Because the question said convex mirror. It then implies f would be negative 10 centimeter. The next information, the question says produces an image of an object positioned 30 centimeters from the mirror. Produces an image of an object positioned at 30. Good. So the question says the object is positioned at 30. So, which means our object distance is going to be 30 centimeters from the mirror. Determine the distance between the object and the image font. So, what do you do? First, try to find the image distance. For you to get the distance between the object and the image, you need to first know the image distance. And mind you, you're expecting a negative answer here. This is how you would know if your step is correct, because you need a negative value for V to confirm that it is virtual. Okay, I'm using it in this space. F is negative centimeter. U was given as 30 centimeter. We need V. Mirror formula 1 over U plus 1 over V equals 1 over F. Isolating 1 over U. Sorry, isolating 1 over V. We have 1 over F minus 1 over U. So this is 1 over negative 10 minus 1 over 30. LCM is 30. 10 in 30 is 3 times negative 1. We have negative 3. Then minus 30 in 30 is 1 times 1, 1. So this is negative 4 over 30, which implies that V is 30 over negative 4. That's negative 7.5 centimeter. Is that a final result? No. The question needs the distance between the object and the image font, because that's what the question needs, and that's what we have to give. You can recall that if, for instance, this is a convex mirror, and you have this to be the principal axis, say the object was positioned here. Recall, the image is going to be from somewhere in here. Object versus image. What the question is from you is the distance between the object and the image. Something like this, from here to here. So, what do? It's going to be the image distance, which is V, plus the object distance, which is U. To be important, you take care of the negative. Negative is going to affect your result here. So your D should be the absolute value of V plus the absolute value of U. Despite V being negative, we still have to use the positive value. So the absolute value of negative 7.5 is simply 7.5. And the absolute value of 30 is still 30, giving us the distance between the object and the image to be 37.5 centimeters. So that takes us to the last part of the question. It says, a plane mirror is viewed from above. A lamp L is placed at a point specified. Sorry, a lamp L is placed at a point specified as a ray from the lamp strikes the mirror at point G. Is that point G? Point O. So technically, the question gave us a mirror and gave us a lamp. The lamp produces a ray towards the mirror as indicated by this line. From figure 1 part of the question wants us to reproduce the diagram above. It says reproduce the diagram above, then at O, draw the reflected ray. 2, carefully mark using a clear dot the position of the image of the lamp. Call it L prime. The question needs you to mark the position of the image, and you call it L prime. 3, give 3 characteristics of the image for me. Okay, let's quickly do that. Let this line here be the mirror, and what we have here being the line representing the ray from the lamp. So this is the position of the lamp here, right? What do? You draw a normal at point O. So this point O here. And you draw another line at the other parts. I duplicate this. Okay. All right. This is this way. Okay. So we have the line drawn on the other parts representing the reflection. The angle of incidence should be equal to the angle of reflection. The question asks you to use a dot to represent the image front. We expect the image to be at the same distance away from the mirror. This is the object distance. This is going to be the image at distance. So the image position we are asked to use our L prime. So this is how you produce this. If you want to obtain this geometrically, you draw a straight line, a straight horizontal line this way, and also measure the distance from here. Measure it somewhere around here. The point of coincidence of that line tells us where to be. But you don't have to go through that stress. The question we want is sketch from you, that's all. Just sketch it, use a dot to represent the position of the image, and also use L prime to denote what the image. That's the instruction from the question. And lastly, according to the question, it wants us to give 3 characteristics of the image font. Characteristics of the image form. Number 1, the image is erect or upright. 2, it is virtual. 3, it is laterally inverted. 4. You still remember what lateral inversion is? The right of the image is to the left of the object and vice versa. Same distance as subjects. Same distance as subjects. Same height as subjects. That also implies what? Unit magnification. And if the first 3 is enough, the question just wants 3 from you, and that's what you should give. And that's the end of this problem.